Hi everyone, I'm Aditya Sauri. Today our topic is dynamic memory allocation. It is also called as dynamic memory management. Dynamic memory allocation is a memory allocation method. The memory will be allocated when the program is executed. Allocation memory at runtime is known as dynamic memory allocation. The problem with arrays is that the length of the array is fixed. There may be a chance of memory overflow or memory underflow. Dynamic memory allocation allows a program to obtain whole memory space while running the program. In dynamic memory allocation, after our purpose is completed, we can release the memory to avoid blocking of the memory. There are four functions for dynamic memory allocations. They are alloc, malloc, realloc, free. Now let us discuss what is dynamic memory allocation and what is static memory allocation and how we can allocate memory and how we can free the memory. Before going to the concept, let us discuss about static memory allocation. So what is static memory allocation? So when we create a variable, so at that time one memory block will be created in RAM. We already know that. So okay, and it is named as A, and for every memory block it has unique memory address. So we already know this concept. Okay, now what's the size of this memory block? 2, because here we created a variable and we gave integer data type, so the size of A is 2. Okay, if we want to increase the size of the memory block, we cannot increase and we cannot decrease also. So here the size of a variable is constant. It cannot be increased or decreased, so the size remains constant. So this thing is called as static memory allocation. Then what is dynamic memory allocation? So in static memory allocation, the size remains constant and the size depends upon the data type which we gave for the particular variable. So we cannot increase or decrease the size. So that is called a static memory allocation. In dynamic memory allocation, we can increase the size of a variable or we can decrease the size of the variable. So we have 4 types of functions. These are predefined functions. So alloc, realloc, malloc, free. So by using these predefined functions, we can increase the size of the variable or we can decrease, and we can free the size also. So here we can change the size. So this thing is called as dynamic memory allocation. Now let us discuss Malloc function. So these functions belongs to the concept of dynamic memory allocation. Okay, the name Malloc stands for memory allocation. The Malloc function reserves a block of memory of specified size and returns a pointer of type void, which can be casted into a pointer of any type. The size is not initialized. So we can see the syntax and the example below the definition. Now let us discuss an example, and I will give the clarification with the help of that particular example. Okay, malloc is a predefined function and it is used to allocate the memory to a particular variable. So with the help of malloc function we can assign an extra memory to the particular variable. So here we can see the syntax. So pointer variable is equal to cache type. So cache type means here we can give the data type, and here star is a pointer symbol, and we already know malloc is a predefined function and it is used to allocate the particular memory block, and here byte size. So malloc is used to create the memory block, so we need the size of the particular memory block. So how much size we need, so that we can say in these parameters. So here we can see the example. So int is a data type, we already know that. So by using int we can assign 2 bytes of block of memory, and malloc function, and size of, we already know the size of is a operator and it is used to get the size of the particular variable or a data type. So int, so int is a data type and we already know the size of int, so 2 bytes. And here we can see the diagram. So already one memory block is created, and if we need an extra memory we can create by using malloc like this. So here pointer is used to connect the another memory block with the help of address. So already we created a memory block, and with the help of this pointer symbol we can connect the new memory block which is created with the help of malloc function. So in this way we can create an extra memory block dynamically. Okay, this function is used mainly in real-time examples. Okay, if we created a program by using integer data type, and unexpectedly if the memory is not sufficient, so we have to create another memory block. So when we are doing static programs, so when we are using static memory allocation, it is not possible, because in real-time examples the customers don't know how to increase the memory, only developers know how to increase or decrease the memory. So it is impossible to increase the memory for runtime programs. So when the clients are using the particular applications, it is not possible. So if we write a code with the help of these particular predefined functions, so if the client need only 2 bytes of memory, so it is possible because we already used int data type. So the data which is passed in it already will store on that particular memory block. But if we need another byte of memory block, how it can possible? So it is not possible, and the client cannot create another memory block also. So for that only here we can use dynamic memory allocation. So for suppose if the client stores a particular data here, that means something on data like this, and if we want another memory block but memory is not sufficient, so in these situations this concept will useful for us. So already the particular memory block is connected with the help of addresses. So the data which is stored first one, after that it continues to another block. So in this way the data will be stored in this malloc concept. Now let us discuss and program with the help of malloc function. Here we can see the program, and we already know about stdio.h, so standard input output, and here I used another header file stdlib, so standard library. So whenever we are using dynamic memory allocation functions, we have to use this header file. So without this header file, these predefined functions cannot be worked. So in DevC, so here I am using DevC editor. In some editors, there is another library function. As include alloc.h. So this is also the header file. It is also used to call the functions, dynamic memory allocation functions, but in this DevC editor stdlib is used. So depending upon the editor, in some editors it will be work stdlib, and in some editors alloc.h will be work. Okay, after that I wrote main function. After that I created two variables. So one variable is used to create, store the data, and another variable is a pointer variable, and here I am using to allocate a new memory space. So p, so this is the malloc statement, syntax. So int star malloc size of int. So this thing I already explained how it works, how it created the memory space in the memory block. So you can see the thing again if you have any doubts. And here I used p equal to ampersand of a. So we already know this thing. So here I am assigning the address of a to p. Now enter the value. So if we gave a value, it will be stored in a. After that I simply print that particular value a. Now let us check the output. So now okay, some error is there. A. Okay, here I forgot, spelling mistake. Okay, now I am running again. So no errors are there. So enter a value. So 10 I am giving. So 10. So in this output there is no change. So all the changes will be held in the memory system only. So visually there is no change because we are giving the value and the value is printing again. So like this only I gave the program. So but the data will be stored in the memory, and if the memory is insufficient, then another block, okay, the another block which we created, there will the data will be stored. So all changes will be done in memory only. Okay, now let us discuss the topic. Okay, another function of dynamic memory allocation is calloc. The name calloc stands for contiguous allocation. The only difference between malloc and calloc is malloc allocates single block of memory, whereas calloc allocates multiple blocks of memory and sets all bytes to 0. Calloc function uses two arguments. So below the definition we can see the syntax and example of calloc function. So in calloc function and malloc function we can create a new memory blocks, but the difference is in malloc function we can create only one block, and in calloc function we can create multiple blocks and we can assign the specific size for each block also. So here we can see the calloc syntax and example. So we already discussed calloc is used to create new memory blocks. So here p is the pointer variable and int is the data type, and okay, we can create any data type, depends upon our requirements. We can create char, float, double. As per our requirements we can use any data type here, and here it is the pointer symbol and it is used to connect the memory blocks with the help of addresses. So we already know calloc is a predefined function and it is used to create new memory blocks. In malloc we can create only one memory block, and in calloc we can create multiple memory blocks. And in this function we are passing two parameters. So first parameter is used to tell how many memory blocks we need. Here I gave 10 values, so 10 memory blocks will be created. If I give 5 memory blocks will be created. Okay, so now memory blocks is created, but we need the size of the each memory block. So in the second parameter we can say that how much size we can give. Here I gave int size, so for each memory block we are giving 2 size. If we give char 1 size, so that means 1 byte of size will be created for each memory block. So here I gave to int, that means each memory block size is 2 bytes. Now let us discuss a program with this concept. Here we can see the program using calloc function. So here I created 3 variables. One is pointer variable and another one is n and another one is I. So we can see the syntax here. So we already discussed that p is a pointer and calloc function is used to allocate memory blocks, and here n. So in n we can decide how many memory blocks we needed, and for each memory block I am giving 2 bytes because I gave integer size here. So wait a second. Okay, so if I gave 5 value in n, that means we are creating 5 blocks and each block size is 2. Okay, now enter values in memory blocks. Here I am running a looping because we are entering more than one value, so it is similar like an array concept. So this concept mainly useful as an array. So we already know what is an array. So array is used to store a value, more than one value in a single variable. But if I give if I give a variable size 5, that means 5 memory blocks will be created. So 1, 2, 3, 4, 5. Okay, if I give 5 values, okay, if I created an array A of 5, that means 5 memory blocks will be created in a contiguous memory location. So if the size 5 is not available in contiguous form, the variable will not be created. So this is the main drawback of an array. Okay, if in the memory block in one location 2 bytes are available and in another location 1 byte is available and in another location 3 bytes is available, for example, imagine like that. But in array, contiguous memory location only will accept to store the values. So this is the main drawback. But with the help of Malloc function, we can interlink each memory block. I already said an example, one location 2 memory blocks and in another location only 1 memory block and in another memory location 3 bytes is available, for example. But in the Malloc function, these all memory blocks will be interlinked each other with the help of addresses, and each value will be stored in the particular memory block. But this thing is not happened in array. And another drawback of array is when we created a size in an array, the size is fixed. We cannot change the size also. So if I created 10, that means it creates the 10, but while running, if I need 12 bytes, okay, 12 memory blocks, I cannot increase the size while running time, and we cannot decrease also. So this thing is not happened in arrays, but in Malloc function we can increase more memory blocks if we require. So this is the main advantage using Malloc function. Okay, now let us see the example. So if I give 5, imagine n equal to 5, that means I equal to 0, 0 less than, okay, okay, for imagine that n value is 5, I equal to 0, 0 less than 5. If the condition is true, it goes here. That means it store a value in p of 0th position. After that it comes here, I plus plus, I value will be 1 because I value is 0, I plus plus means 1. So 1 less than 5, condition true. If the condition is true, it jumps here and it stores the value in p of 1 position. Like that it runs a loop up to 0 to 4 and it stores 4 values in p. So after that I plus plus, I will become 5 at last, 5 less than 5 condition false. So after that it breaks the for loop statement. After that it jumps here. So same loop will be repeated here also. I equal to 0, 0 less than 5 condition true. If the condition is true, it goes to the print statement and it prints the value which is stored in p of 0. After that I plus plus, I value 1, 1 less than n. If the condition is true, it prints the value which is stored in p of 1. Like that it runs a loop 5 times and it prints the 5 values. So now let us check the output. So here I am giving 5, that means n size is 5. So in memory 5 blocks will be created and each block is 2 bytes, because like that only we wrote the syntax in the program. Now I am giving 5 values. So now we can see the output. So it look like an array concept, but it is not an array, because in array every value will be stored in a contiguous form only. But in Malloc function, each value can store anywhere where the memory will be available, and each memory block will be connected with the help of addresses. So this is the main advantage using Malloc function. Now let us discuss another function called free. So free is also a predefined function which is available in dynamic memory allocation. It deallocates the memory pointed by the pointer. Dynamically allocated memory using Malloc function or Malloc function does not get written on its own. The programmer must use free function explicitly to release space. And here we can see the syntax free and in parameter PTR, that means pointer variable. So now let us see an example using free function. So now let us discuss the another example using free function. So I am using previous example which is used in Malloc function. So here I am adding free and I am writing here p. So here p is the pointer variable, we already discussed about that one. Now let us check the output. Okay, I am giving 3 size 1 2 3. So 1 2 3. So what is the use of free function? So in Malloc and Malloc function we can create or allocate the memory blocks in memory, but free is used to deallocate the memory. So if any memory blocks are there which we are not using, we can free that particular memory, because to be a best programmers we have to save the memory size as much we can. Okay, for example, if I created int data type, we already know the int size is 2, but if we use only 1 byte and another byte is we are not using at all that 1 byte, but if we like to save that memory, that means free, we can use this particular free function. So with this help of free function we can free the memory block and we can save the memory. Now another function is realloc. If the previously allocated memory is sufficient or more than sufficient, then you can change memory size using realloc. Realloc uses 2 arguments. PTR is a pointer to the block of memory for which the size is to be altered. New size indicates increases and decreased size. So below the definition we can see the syntax. So realloc function is used to allocate and deallocate the memory. So we already did these things with the help of Malloc, Malloc and free, and by using realloc we can allocate and deallocate also. While allocating the memory there is no problem at all in realloc function, but when we are deallocating the memory we can face some problems while writing programming. So this is the drawback in realloc. So these are the concepts in dynamic memory allocation. Thank you.